So let's start off with a review of linear systems. So here we have two lines, so we have a linear system, and I want to talk about what their solution is, and we can actually see exactly where they're going to intersect, and that is the solution, where they intersect. So they intersect at that coordinate point 2, -1. And what that means is if you were to plug in 2 for your x value, let me fix this here. If you were to plug in 2 for your x value and -1 for your y value, you would get a true statement for both equations. So I could plug in 2 for this x, -1 for this y, and get a true statement. I could plug in 2 for this x and -1 for this y and get a true statement there because that's where they intersect. So that is a true point for both the red line and the purple line. Okay, now let's kind of pretend that we did not have this graph here and I was only given the equations. Could we find the solution only given the equations? And when I look at each of these equations, they're actually both solved for y. So I have y isolated or by itself in both equations. I'm just going to go ahead and choose to focus on the y being isolated in the first equation. And so we have that y is equivalent to -2x plus 3. So since y is equal or equivalent to -2x plus 3, that means those two things are interchangeable. They're both equal. So once I've identified a variable like y in this case that's interchangeable with something else, then I'm going to use the other equation and essentially rewrite it, but I'm going to leave the interchangeable variable blank. So in this case, I'm going to leave y blank. Or I might even write it down for a second so that we can see that this is just the same thing as the other equation. But now I'm going to go ahead and erase y, and I'm going to say, well, what was y interchangeable with? Y was equal to or interchangeable with -2x plus 3. And once I've done that move, now I have an equation with just one variable, one letter. I have only x's, so that means it's ready to solve. I like to keep my variables like I keep my attitude, positive. So I'm going to choose to add 2x to both sides over here. So let's go ahead and do that move. So now I have 3 is equal to 3x minus 3. Let's go ahead and move this -3 to the other side. Okay, so we're at a 6 is equal to 3x. One last move, and I have my x. And let's go ahead and kind of compare what I have so far. So right now I have the x is equal to 2. And let's compare that with the solution that we already knew. What was my solution? The intersection point, which is a coordinate point. So that's an x value of 2, which is why I got an x value of 2. But then there's a y value of -1. So I need to make sure that I know how to find the other coordinate. So if I found x, I need to also find y. And sometimes you'll find y first and you need to find x. So right now for us, we have an x value of 2 and I need to find y. Well, where can I find something that will tell me what y is equal to? Well, actually, I go back to right here where I started and it tells me I'm looking for y, right? Well, here I have y equals all that stuff. Here I also have y equals all this stuff. And since it's a solution for both, then I get to pick. I could either pick the top one or the bottom one, and it doesn't matter. I'm going to go ahead and pick that bottom one, the red one. So the red one says, it's a little bit easier, that's why I'm going to pick it. It says y equals x minus 3. Okay? So now, well, what do we know? Well, right now, I know that x is 2, because I already found that x is 2 right there. So let's go ahead and replace x with 2. And what are we trying to find here? We're trying to find y. So y is equal to x minus 3, or 2 minus 3, because we found x to be 2. So now I just have that y is equal to -1, and yeah, now we can check, oh yeah, that's what I saw on the graph as well. So I know I'm looking good. So whenever we're solving these, we want to make sure that we find coordinate points. So if you find x, then find the corresponding y. Sometimes you'll find y first, and you'll need to also find the corresponding x. Now we're going to go into quadratic systems. So here I have one quadratic equation, one parabola, and one line. And so we can see that this parabola, which means there's going to be an x squared in there, is moved down 3 from the origin. So then that equation would be x squared minus 3. And then this line here goes through a couple of intercepts, -1 on the y and +1 on the x. So if I was going to write that in standard form, it would turn into x minus y is equal to 1. Okay, now I'm going to go ahead and try to solve this. Now, maybe first, before we go into the algebra of solving it, let's go ahead and take a look at this picture here. And this system is going to intersect in 2 places. So it's going to intersect right there, so that's going to be -1 and -2. And then it's also going to intersect right here. So with quadratic systems, it kind of opens it up into crossing in more than one spot. So it doesn't have to cross in more than one spot, but it certainly could, as it does in this case. So this time I have 2 different solutions. And notice there is an x and a y for one of the solutions and an x and a y for the other solution. So technically there's kind of like 4 numbers to solve for the 2 coordinate point solutions. Okay, now let's go ahead and take a look at this system over here in equation form, and let's see what we can do with it. And again, this time I notice that the y is isolated on the first equation. I actually don't have anything isolated on the second equation, so I'm going to focus on finding my equivalent or replaceable variable on that first equation. So here y can be replaced with, or is equal to, x squared minus 3. So let's go ahead and take this second equation here, and maybe at first I'll just go ahead and write it out exactly how I see it. So x minus y equals 1. And I wrote that y kind of funny. I left a bunch of space around it because y is what we're going to be replacing. And so I'm going to erase y, and I'm going to say, well, what are we going to replace y with? What is y replaceable with? Well, y is replaceable or equal to x squared minus 3. So I'm going to go back here, erase that y, and replace it with x squared minus 3. Okay, now something really important, whenever we are replacing a variable with something else, it's really important, especially if I'm subtracting, to make sure that I put it in parentheses, because I'm subtracting that entire amount. And those parentheses are there to remind me that that negative needs to distribute out to everything inside. Okay, so let's go ahead and continue this and see what we get. So now I have x, that negative distributes, so that's going to be negative x squared, and then negative 3 is going to be a plus 3 is equal to 1. Okay, now with quadratic systems, we're going to end up with some kind of x squared. And some kind of x squared means that I can't necessarily solve it like a linear. I can't just get x alone. I'm likely going to have to do some kind of quadratic procedure, like factoring, or maybe complete the square, or maybe the quadratic formula. But what I can do to start off is get everything together all on one side, and it's going to be much easier if we keep our x squared term positive. So right now the x squared term is negative on the left. So what I'm going to do is I'm going to go ahead and move this term to the right and essentially move everything to the right so I can have it all together and also have that x squared term be positive. Okay, so I could write, say, plus x squared and plus x squared on both sides, but instead I'm just going to go ahead and draw an arrow because I'm going to move that to the right side. And then similarly, I'm going to move the plus 3 to the right side, so that's going to become a negative 3. And similarly, move this positive x to the right side, so that's going to become a negative x. So let's go ahead and see what I have on the right side now. So this negative x squared becomes a positive x squared when I move it. that positive x on the left becomes a negative x when I move it. The positive 3 becomes a negative 3 when I move it. And then remember this 1, that's a positive 1 on the right, and it's still there. So that's still going to be there, so that's going to be a positive 1. And I now have nothing left. Okay? Okay, and then we're of course going to simplify it. So that's kind of just one way to show your work. And if that didn't quite make sense to you, I can kind of write in the other way to show our work, kind of the traditional way to show our work here. And so I could say, well, let's go ahead and go plus x squared. If I do that to the left side, I have to do that to the right side. And then if I were to do minus x to get rid of the x, I would have to go minus x over here. If I was going to go minus 3 on this side, I would go minus 3 on this side. And that's kind of the traditional way to show your work as well. Okay, so now I have 0 on the left. On the right side, we have x squared minus x and then minus 2. So now I have everything all together on one side, and I have my x squared term positive. So now let's see what I can do with it. Let's try to factor it and see what happens. So if I was going to factor it, there would be a negative 2 on top, a negative 1 on bottom. And let's think about two numbers that would multiply to negative 2 and add to negative 1. Okay, and how about negative 2 and positive 1? So negative 2 times 1, that multiplies to the top. Negative 2 plus 1 adds to the bottom. So that's looking pretty good. So now I can go ahead and rewrite this. Remember, I'm going to keep my 0 and keep my equal sign. And now I have x minus 2 and x plus 1. Okay, but again, I want to solve for it. I want to get my solutions. So that's going to be x is equal to, well, what minus 2 would be 0? 2 minus 2 would be 0, so that's a solution. And also what plus 1 would be 0? Negative 1. So negative 1 is another solution. Okay, now, so that's pretty good. I've kind of got some kind of answers going on here. I got to an end. But before we move on and get too excited, let's go ahead and compare that to what we got when I looked at the graph. So when I looked at the graph, what were my solutions? Negative 1, negative 2. Well, remember, negative 1 was an x value. That's why I have negative 1 for an x value. And then over here, I have the coordinate point 2, 1. Well, 2 is an x value. Oh, and here 2 is an x value. So what I have is I found the two x values, but I still need to find their corresponding y values. So looking right here, where I have my x values of 2 and negative 1, let's go ahead and write those start of the coordinates. So I have 2 as an x value, and then I have negative 1 as an x value. And I still need to find their corresponding y values. So I still need to find those corresponding y values. What can I use to find y values? Well, let's go ahead and come back to where we started here. These were my two equations that I started with. This was the beginning, the problem. And I can use either one of those to find my y values. I might maybe just choose that first equation just because y is already solved for. So it says y is equal to x squared minus 3. And let's go ahead and take a look at this here. In the first coordinate, I know that my x is 2. So I'm just going to go ahead and plug in 2 here. And now we have 2 squared, which is 4. And then 4 minus 3 is 1. And let's compare that here. So I got a coordinate point of 2, 1. Oh yeah, that's what we got when we graphed it right there as well. Okay, let's go ahead and do the same thing for the second coordinate. So I'm going to use that y is equal to x squared minus 3. But then my x here is negative 1. So let's go ahead and plug in negative 1. And whenever you're plugging in, especially a negative value, into something that's going to be squared, then you want to make sure that you put that in parentheses. Because a negative 1 squared means negative 1 times negative 1, which is really a positive 1. So now I have 1 minus 3, and that's going to be negative 2. So it looks like my solutions are 2, 1, and negative 1, negative 2. Let's just go ahead and make sure that's what I got. Oh yeah, negative 1 and negative 2, and 2 and 1. So those are my solutions.